Previously, we'd been doing exercise 1C, question number 1, question number 2, and question number 3. Now, it's time to do the remaining two questions, question number 4 and question number 5. Both of these are word problems, and we'll learn easier ways to solve word problems. Now, let's go through the question number 4 first. Question number 4 says, James wants to cover a floor measuring 90 centimeter by 120 centimeter with square tiles of the same size. Given that he uses only whole tiles, we need to find out part A, the largest possible length of the side of each tile. Part B is the number of tiles he needed to cover the whole floor. Now, word problems are pretty daunting. They are complicated, have tons of data, and a lot of fictional characters. It's like a monster staring during the freeze. It doesn't have to be. All you need to do is look for the key information. For example, we're going to read the question number 4 again, and we're going to extract the key information that is going to help us solve the mathematical equation. Let's read it again. James wants to cover a floor measuring 90 by 120 centimeter. The key information here is, first of all, a floor. Let's highlight that. Then the dimensions of that floor, that is 90 by 120. We draw that for graphical representation. Let's say we have a floor, it's 120 by 90 centimeter. Moving on, he needs to cover this floor with square tiles. What is a square tile? Square tile is the one that has same length and the same width. Given that he uses only whole tiles, what does that mean? Whole tile meaning we're talking about common factors here. We need to find out the largest possible length. Now we're talking about the highest common factor. So we have extracted all the information. We need to cover a floor of 90 by 120 with square tiles using the whole tile, and now we have to find out the largest possible length of that tile. We have to find out the HCF. We have extracted the information. Now it's a mathematical problem. How do you find the HCF between 90 and 120? You use the prime factor method. We are going to use the prime factor method by division. Let's put 90 and 120. We divide that by 2. The answer is 45 and 60. We divide that by 3. The answer is 15 and 20. You divide that by 5. The answer is 5 and 4. No common factor after that. So we multiply 2, 3, and 5, and we have 30 centimeters. 30 centimeter is the largest possible length of side of that tile. Since we're talking about a square tile, we have 30 centimeter as the length and 30 centimeter as the width. Let's draw that. 30 centimeter is the length and same as the width of that tile. Now moving on to the part B. The part B says the number of tiles he needed to cover the whole floor. Number of tiles. That's a simple area question. You need to find out the area of the whole floor, that is 90 by 120. That is 10,800 square centimeters. And we find out the area of the tile, 30 into 30 is equal to 900 square centimeters. All you need to do now is divide the area of the floor by the area of the tiles, and you will get the number of tiles. 10,800 divided by 900, we have 12 tiles. It's a pretty simple question. You need to look for the key information. Moving on to the question number 5C. Paul has 3 pieces of rope with lengths of 140, 168, 210, and he wishes to cut the 3 pieces of rope into smaller pieces of equal length. Part A of the question is, what is the greatest possible length of each of the smaller pieces of rope? Part B is, how many of the smaller pieces of rope of equal length can he get all together? So again, a word problem, again a monster. You need to look for the key information. Let's read the question again. Paul has 3 pieces of rope. So the key word here is 3 pieces of rope with length of 140 centimeter. Let's draw that one. 168, we draw that one. 210, we have a 210 centimeter rope. He wishes to cut the 3 pieces of rope into smaller pieces of equal length. Smaller pieces of equal length. What we're talking about here is a common factor. Part A of the question is, what is the greatest possible length? Okay. Whenever we talk about greatest possible length, we're talking about HCF, highest common factor. How do we find HCF? You use the prime factorization method. Prime factors of 140, 168, 210. Now, what's common between the prime factors of these three numbers? We have 2 and we have 7. If you multiply these two, the answer is 14. So 14 is the greatest possible length of each of the smaller pieces of float. Now question number 5, part B, is the same. You need to look for the key information and then you have to solve the question yourself using your understanding. Word problems are not really that difficult. You need to remember the rule, look for the key information. That's going to help you a lot. Revise the exercise and I'll see you soon. Bye bye.